Welcome back to our Chem 152 video series. In this video, we'll learn how to determine the order of a reaction from using the graph of the reaction. In this table, I've listed time data and molarity data. As the reaction continues and time passes, the molarity of the reactant is going down, starting from 0.1 and stopping at 0.02 molarity. Based on this, we can find the order of the reaction: zero order, first order, or second order. To begin, let's start by examining if this reaction is zero order. To do that, we will select the time and molarity data, and then we will create a scatter chart in Excel. To create the scatter chart, we'll click the Insert button at the top, and in the Charts section, we'll select the dots for a scatter. We'll click the first option in the scatter and get our chart. Once we have our chart, we can right-click on one of the dots. The option we're looking for is the Add Trend Line option. We'll click on that next. This will bring up a submenu on the right side. We want our line to be linear. This is already selected, so we'll leave that as is. We will click the two check boxes at the bottom, Display Equation and Display R squared on the chart. The equation is obscured by the line and the dots, so we will move that out of the way. And we notice our R squared value is 0.813. We're looking for an R squared value that's as close to 1 as possible, and 0.813 is fairly far away, so this tells us that this is probably not a zero order reaction. However, this could be a first order reaction, and to find whether it's first order or not, we'll go to column C. I've labeled this Ln of the molarity. We'll be taking Ln of all of our molarities from column B, and we'll say equals Ln, open parentheses, and then click on that molarity in B2. Close the parentheses and press enter, and this will give us the natural log of that molarity. We will hover our mouse over the bottom right-hand corner of that cell to get the black cross. Click when we see the black cross and drag it down to get all of our natural logs of our molarities, thus completing column C. Now, we will select the numbers in column A, press the Control key, and select all of the numbers in column C. This selects column A and column C. And then we'll create another scatter by going to Insert and clicking on the scatter option. Now we right-click on one of the dots and say Add Trend Line once again, and get the equation and the R squared. Notice that our R squared for this line is 0.947, definitely higher than our zero order attempt, but it's not very definitive. It might be first order, but we'll have to check second order because checking second order may give us a higher R squared. We'll return to our data, and in column D, we'll say equals 1 divided by the molarity located in B2. Press enter. Once again, we will use the black cross to complete column D. Now we select the numbers in column A and the numbers in column D and insert one more scatter. Right-click on one of the dots once again, add our trend line, display our equation and our R squared, and notice now our R squared for the second order graph is exactly 1. So this tells us that the highest possible R squared will match up to the correct order. Zero order was 0.813, first order was 0.947, but second order is exactly 1, or at least close enough to 1. So we'll say second order gives us the best R squared, and so this reaction is second order. Also, we can read the rate constant directly off the graph. Notice that the slope of the line for our second order equation is 0.01. Once you complete your graph, your rate constant k is equal to the slope. Therefore, in this instance, k is equal to 0.01. The k's for the other graphs will not matter in this instance because we are not 0 or first order. Use only the k from the correct line. Thank you for watching, and we'll see you again soon.